All right, geometry. Let's talk about the law of sines and cosines. And these are two techniques used to find missing angles and side lengths of triangles. And it is typically used when you do not have a right triangle. So we are going to solve triangles, find all angles, all side lengths. But this is specifically for non-right triangles. Now, these techniques do work for right triangles. But if you have a right triangle, it's easier to just channel your SOHCAHTOA and solve that way, because these formulas are a little bit more complex. So starting with the law of sines, if we have a triangle ABC, and it is convention that if you have a lowercase a and a capital A, the lowercase a represents the side opposite angle A, and you'll see that with lower b and cap B, and lowercase c and capital C. And to set up the law of sines, it's kind of nice. You just want to lock into an angle and its opposite side. So you have A and its opposite side A, angle cap A, and side length little a. And you just do little a over sine of angle A. And then you pair it with another one. You can choose angle B with side length B. So B over sine B, and then C, side length C over the other C, the angle C. And you only need two of those, but it works with all three. So you choose whichever two are the best ones to use, and that is your law of sines. A very quick explanation for why the law of sines works, because this is a fairly nice explanation. We have a right triangle here, the same one that was over here, and I have dropped an altitude from vertex C to the opposite side AB, and we will call that H because it is the height of the triangle. And if we look at the two right triangles I just created, we have right triangle yellow on the left, and we have right triangle green on the right. And in that yellow triangle, it is true that the sine of angle A would be the opposite side, and the opposite is H over B, the hypotenuse B. And I can multiply that by B to find out that H is equal to B times the sine of angle A. Well, I could do the same thing with the green triangle over here. I could say that the sine of angle B would be the opposite H over the hypotenuse, which is A, and I can multiply by A to find out that H is equal to A times the sine of B. Well, if H is equal to B sine A and H is equal to A sine B, then that means those two things must be equal to each other. So I can now say that B sine A, my B's are all messed up today, B, that's a little bit better, sine A would equal A times the sine of B. And then to make it look more like these equations over here, we can divide both sides by the sine of A and the sine of B. Divide this side by the sine of A and the sine of B, and I just noticed a typo. I wrote a lowercase b right here. I'm doing angle B, so that'd be capital B. And when you divide by sine A and sine B, you will see that on the left side, the sine A's can divide out. On the right side, the sine B's can divide out. And what you are left with is B over sine B. Sine cap B would equal A over the sine of cap A. And that gives you the first two right here. That's a very quick explanation for the first two. And then to involve angle C, we would simply need, I say simply, but we would need to drop an altitude from A to the opposite side or from B to this opposite side and repeat the process to show that there's a similar relationship with angle C and side length C. Now, one thing to remember with the law of sines, and I am injecting this into the notes, which it was not part of originally, is that in order to use the law of sines, at a minimum, you have to be presented with two angles and their opposite sides. So that's four pieces of information, two angles and their opposite sides. And one of those four has to be a variable. So that's what you're looking for. You're looking for angle, opposite side, another angle and its opposite side, and a single variable somewhere in there. And so let's talk about how we will use the law of sines to find missing angles and side lengths and stuff. And so number one, now I've gone ahead and drawn these triangles, and maybe I shouldn't have. Hey, so I've decided to hide those triangles because they are not originally drawn on your notes sheet. And what you need to remember is that the convention in naming angles and side lengths and triangles, if it's not drawn, is that if you see a capital angle representing a capital letter representing the angle, the lowercase letter would be opposite that angle. And then right here, I see angle B and lowercase b, it is understood that those are opposite each other. So right off the bat, I could go ahead and set this up. I know that it's going to be the side length B over the angle, the sine of the angle that is opposite that side length, so will be sine 93, is going to equal side length A, which is actually the unknown, over the sine of the angle A, which is sine of 48. So you could go just by knowing that lowercase letters and capital letters are opposite each other. I am very much a visual person, so I love drawing the triangle and looking at it because just the visual, seeing the angles and their opposite sides really helps me process these and set up the equations better. It's not absolutely required, but I do think it's safer to do that. So I would go ahead and set up the equation after drawing it. I'm just going to bring this down here in pieces, apparently. All right, you come too. All right, so we have this set up. There we go, bell's over. So we have this set up, and now I need to solve for A. And in the law of sines, it's not always necessary, but it may be easier just to cross multiply from the beginning. So I will have 15 times the sine of 48 is equal to A times the sine of 93. And then if I'm trying to solve for A, I could divide both sides by the sine of 93, divide by the sine of 93, and that will give me whatever A is equal to. So we'll pull out our calculators, and I strongly recommend, and it may be a little bit cumbersome for you, but I strongly recommend in your calculators to keep things in terms of sine. Like, don't write down the decimal for sine of 48 and then the decimal for sine of 93 and then use those decimals, because you'll end up rounding those decimals. And if you use rounded intermediate steps, that often creates an exaggerated rounding error in the end, and your answer will not be exact. So what I'm going to do is I'm going to punch it in exactly like this. It's 15 times the sine of 48. So 15 times the sine of 48. The multiplication dot symbol is not necessary, but it makes me feel better. I'm going to arrow down to my denominator, punch in the sine of 93, and I will hit enter and double check that you're in degree mode, which I am. You always want to make sure you're in degree mode. Hit enter, and I'm getting 11.16 for my A. A equals 11.16. Okay, and then one thing I'm going to do before I move on to the next question, I want to make sure my answer is just reasonable. This doesn't guarantee that it's correct, but I noticed that my angle 48 degrees is less than 93 degrees. Therefore, the side opposite 48 should be less than the side opposite 93. And I did get that. That doesn't guarantee that you are correct, but at least it's reasonable. If I set this up and I solved for A and I ended up getting something like A equals 19, I immediately know that I'm wrong because it has to be something less than 15. So take a quick second when you're finished with these problems and just confirm that the side lengths or the angles that you're finding are at least in the correct order as far as least to greatest. So let's go on to this next one. And I've already drawn this triangle for you. We are looking for angle A, and here's our setup. So again, I'm locking into angles and their opposite sides. So we have 43 is opposite 9. We have X is opposite 13. And so we can set that up as 9 over the sine of 43, 9 over the sine of 43. Really, it's 43 degrees. I probably should be more technical with that. And then is equal to 13 over the sine of X. And I will cross multiply. That gives me 9 times the sine of X is equal to 13 times the sine of 43. And I'm trying to solve for X. I'm going to need to move the 9 over. So sine of X is equal to all of this, 13 sine of 43 degrees divided by 9. And then to separate the X from the sine, remember, if you're solving for an angle, you use inverse trig. I'm trying to find the measure of an angle, so I'm going to do the inverse sine of all of this. And again, I'm going to punch it in the calculator in one big step, rather than several intermediate steps. Because again, if you are writing down decimals and rounding and then using those rounded decimals in later parts of the problem, it often exaggerates your error in the end. It is much safer to plug it in exactly like that. I'm going to pull up my calculator, and I think I can see everything there. I can. So I need the inverse sign, second inverse sign. I'm going to hit my top bottom fraction, so everything's easier to see. 13 times the sine of 43 degrees, arrow down to my denominator. And my denominator is 9, and hit enter. And I'm getting an angle, or I'm sorry, yes, an angle of 80 points, and that would round to 10, 80.10. And once again, I'm looking at that. Is 80 good? Yes, it is, because 13 is greater than 9. Therefore, this angle opposite 13 should be greater than the angle opposite 9, and it was. So I'm happy with that answer. Okay, moving on with the law of sines. Now we have a bigger problem. Notice this time in number 3, we are looking for 3 unknowns rather than just a single unknown. And again, if you want, you could set it up. You could set it up just using the fact that I know angle M is opposite side length M. Angle L is opposite side length L. Angle N is opposite side length N. So you can set it up without the picture. But again, I feel better having a picture. So there's my picture, my drawing of my triangle for number 3. Move that up a little bit. And I'm going to start setting up. And when I'm setting up the law of sines, I want to focus in on the one angle and side length relationship where I have both pieces of information, and that happens right here. That happens right here. And so I'm going to set up the law of sines. When I use the law of sines, I'm going to absolutely use angle N and side length N both whenever I do that. However, as I was circling that, I noticed one of my objectives is to find the measure of angle M, and the measure of angle M is going to be easy because we have 2 angles of a triangle. I'm just going to subtract those 2 from 180 to find angle M. So let me do that really quick. So 180 minus 125 minus 48, 28. And I'm getting an angle of 27 degrees for M. So I'll go ahead and put that in here. 27 degrees is angle M. Now, to solve for M and L, we will have to set up the law of sines. And so to set up the law of sines, again, you want to use given information. They gave me 11.4 and 28. So I'm going to start with that, 11.4 over the sine of 28 is going to equal, and I guess I'll go ahead and solve for side length L. So I'll do side length L over the sine of 125. And then we will cross multiply and solve that. So I'll have 11.4 sine of 125 is equal to L times the sine of 28. And then to solve for L, we'll divide both sides by the sine of 28. Divide by the sine of 28. And these are all degrees. I should satisfy the gods of math by putting degree symbols on my angles, but I'm being a little bit lazy here. And so L, I'm going to go ahead and throw all of that in a calculator to find my side length L. So here's my calculator, and I do it all in one big step. Now I'm not solving for an angle this time. There's no inverse trig needed. So it's just going to be straight up 11.4 times the sine of 125. And I am in degree mode, so we're good there. Go down to my denominator. And I need to punch in the sine of 28 in the denominator. That looks like it is correct. Hit enter, and I'm getting 19.89. So L equals 19.89. I apparently decided to swap to red here. Good. And then to solve for M, we'll just have to set up again another law of sines. And this time I'll have to use the 27 degrees that we found earlier. And so I would set up the sine. No, I'm not. I'm going to go say M over sine of 27 is equal to, and I'll go back to the given information. Don't use this rounded value for L. I want to use the information that was actually provided, 11.4 over the sine of 28. And we'll punch that in. Let's see, I'm going to, in this case, I'll go ahead and cross multiply just to be consistent. So m times the sine of 28. My writing is getting worse and worse as I work through these problems. Sine of 27. And then finally, we will divide by the sine of 28. To get our final answer. So I'm going to my calculator again. I'm going to use my top bottom fraction, 11.4 times the sine of 27. And notice this time I forgot to hit the multiplication dot between 11.4 and sine, but that's not a big problem. The calculator understands that we are multiplying those. Divide by the sine of 28, hit enter, and I got 11.02 for m. M is 11.02, so I'm going to go back up here. M is 11.02, and then really quickly, I'm going to look at all of my answers and make sure that they are lining up correctly. My largest angle is 125. L is my largest side. My smallest angle is 27, and M is my smallest side length, not by much, but it is less than 11.4. So I am happy with that answer. And if you want to give number 4 a shot, you can do that. I have already worked it out, and I'm about to unveil the answer. But if you want to look at it, if you want to pause the recording and try working it out and then check your answer, you can do that. And here comes the answer. There we go. And so this time they gave us 2 sides and an angle. So we had no choice but to start with the law of sines. And for this one, we did have to go with inverse sine to finish getting one of the angles. It didn't matter which one you started with. I chose to start with C. Once I had that angle, I could subtract from 180 to get my other angle, and then we set up law of sines again to get the third side. But there's how we solve 4. And then I'm going to move on to number 5. And number 5, we have something of an application here. We have a baseball or a softball illustration here. We have a right fielder that fields a ball that's kind of between first and second base. So the ball goes between first and second base. The right fielder fields the ball, throws it to second. We have these measurements, and we were wondering how far did we throw that ball. And so we have the side length x, its opposite angle 40. So we have x over the hiccups there. We have x over the sine of 40 degrees is, and then, I need that angle. Oh, here it is. I forgot I've already worked this out. Okay, so then this angle right here, we did have to subtract from 180 because that's the side length we had. So I needed its opposite angle. And so we subtracted those 2 from 180, and that angle was 72. So we have 60 divided by the sine of 72. And then just a quick point regarding the law of sines. As we have set it up, we have been putting the side length over sine of the angle every time. It turns out that it is perfectly okay if you want. You can actually put the sine on top. So if you were doing sine of 68 on top, that's perfectly fine. Sine of 68, well, you can't do 68 because we don't have the opposite side. I could do the sine of 72, because I do have that angle, sine of 72, over its opposite side is 60. And as long as you keep the same thing on top, it doesn't matter where you start. So if I put my sine of 72 on top, then I need to put the sine of 40 on top on the other side. So I will, on occasion, do it this way, and sometimes I'll put the side length on top, and it doesn't matter because once you cross multiply, you'll end up with the same thing. So I'm going to finish solving this one. Over here, we'll cross multiply, and I'll have x times the sine of 72 is equal to 60 times the sine of 40, and then we'll divide by the sine of 72. Yeah, my writing is terrible. Absolutely atrocious. Divide by sine of 72. We'll punch that in to get our answer. And 60. Move my head out of the way. 60 sine. I forgot to do my top bottom fraction. Not a problem. If I do it this way, it's okay because the calculator understands the order of operations. It just doesn't look as pretty in the input. I'm going to hit enter, and I'm getting 40.55 for my answer. And 60 is larger than 40.5, and the angle opposite 60 is larger than the angle opposite 40.5. So I am happy with that. All right, so we are about 20 minutes in. That is the law of sines. Now let's talk about the law of cosines. And the law of cosines is It's uglier. There's just no mistaking that. It is uglier. And the law of cosines, again, is used to solve triangles. Typically, when you have a non-right triangle, we're going to skip the proof of the law of cosines. But the law of cosines starts off looking kind of like the Pythagorean theorem. As a matter of fact, if we just blocked out all of this stuff, it is the Pythagorean theorem. It looks like the a squared plus b squared is c squared type stuff. But remember, we do this with non-right triangles, so the Pythagorean theorem doesn't quite work. And so we basically just have an adjustment that allows this to work. And the cosine right here, it kind of blends in all together, but that is side length B, side length C times the cosine of angle A. So if you want to squeeze some parentheses around that so that the cosine function is kind of separated from the other side lengths, that may help. And in this setup, what you want to do is lock in to an angle and its opposite side. So right here, I have angle A and its opposite side A. And if you notice, in the version that used the angle A, the angle and its opposite side are also on opposite sides of the equation. If you look at side length B and angle B, the one that uses angle B has side length B on the opposite side. They're on opposite sides of the triangle and opposite sides of the equation. Same thing with C. That might help you keep this straight as you are setting it up. Just remember the side length and its opposite angle are also on opposite sides of the triangle. And when you use the law of cosines as opposed to the law of sines, these are the situations that prompt you to use the law of cosines. Again, you're looking at non-right triangles, but you are given all three sides and one angle, and the variable has to be either the angle or its opposite side. So that's what we're looking at, all three sides, one angle, so 4 pieces of information again, and the unknown has to be either the angle or its opposite side. You can also think of it this way. Maybe you're given all three side lengths, so that's like a side situation, and you need to find one angle. Or you're given two sides and the angle between them. So that's a side angle side. You have two sides and you're given the angle between them and you're looking for the third side. So I don't know if that helps you much with knowing when to use law of cosines, but let's look at a couple of examples of the law of cosines. And again, I would draw the triangle. It just helps me process things if I have the triangle drawn. But again, if you want to try to set it up, just knowing the convention of capital letter, lowercase letter, and one is the angle, one is the opposite side, that's okay. Here is the triangle that matches number A. And let's look here. And the situation we have here, we are given, where's my pen? Come on, pen. Work with me. There we go. We have two sides. We have the angle between them. So this is that side angle side thing, two sides and the included angle. And notice that the variable, what I'm looking for, is the opposite side. And I'm going to lock in to the opposite side and the angle. And we start this almost like the Pythagorean theorem, where you do the opposite side and you treat that kind of like it's the hypotenuse. It's not truly a hypotenuse, but in the Pythagorean theorem, the hypotenuse is the one that's by itself. So here, the opposite side is by itself. I'm going to start off with a squared equals b squared. So this will be my b. Oh, actually, that will be my c. It's opposite c. So there's my c. So it'd be 14 squared plus, this is my b down here, 29 squared, minus 2 times 14 times 29. So b squared plus c squared minus 2bc cosine of the angle between them, 52 degrees. And boy, that's scary looking, isn't it? But this is actually going to be very quick. This one's going to be nice because if you notice, my variable, what I'm solving for, is almost by itself already. It's squared. We can take care of that later. But everything on the right side of this equation is all numbers. 14 squared minus 29 squared minus 2 times 14 times 29. And cosine of 52 is also a number. It's a weird number, but that's just a number. I'm going to make this easy on myself, and I'm going to go straight to my calculator right now. Instead of trying to do this in pieces, I'm going to trust my calculator and its order of operation abilities, and I'm just going to throw it all in one big step. Minus 2 times 14 times 29 times the cosine of 52. And I punch it all in at once, being very careful that you punch it in correctly, because you can see that it's such a long equation. It's run off the side and you can't double check anymore without having the cursor back to the left. So I'm going to hit enter, and I got 537.083, But remember, that is a squared, 537.083. And to finish solving for a, we will simply square root that, 537.083. And back to my calculator, I will do the square root. And here's a little secret for you. If I want to do the square root of that previous answer, notice above the little negative sign is ANS. I'm going to hit second ANS, and it will square root the previous answer. And the advantage to that is it square roots the exact value rather than a rounded value. And I'm getting 27, crap, I just lost it. 23.175. So 23.175 would round to 23.18. And there is your length for side length A. Cool. All right. Okay, so let's continue with number 2 with the law of cosines. And in this one, you'll notice that the given information is all 3 sides. So this is one of the side situations. We are looking to solve for x, or angle C, which I labeled x. And remember, you want to lock into the angle and the opposite side, because the angle and its opposite side must be on opposite sides of the equation as well. And so back to the Pythagorean theorem type thought process, the 8 is going to be the one that needs to be by itself. So it's 8 squared. 8 squared is equal to 5 squared plus 9 squared. 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of angle C, which I have labeled X here. I'm leaving it as C. Maybe I'll erase that X. But angle C right here is the unknown. And now we need to solve this equation. And this one is going to be a lot more complicated than the previous one, because my variable C is mixed in with a whole bunch of other stuff. I've got to isolate the C by moving everything else over. Number 1 was not as bad because a squared was already by itself. So with the law of cosines, this is one where we need to do a little bit of work in between. And I'm going to start by squaring the 8. That's a tough one. 8 squared is 64. Now, on the right side, you have to be very careful with your order of operations because it's very easy to mess this up. I'm going to go ahead and I can do 5 squared plus 9 squared because those are kind of isolated and separated from the 2ab cosine C stuff. So I'm going to punch 5 squared plus 9 squared in. Let me clear all this stuff out. 5 squared plus 9 squared. So 25 plus 81 is 106. I guess I didn't have to punch that in a calculator. So that's 106. Then I will subtract, and I need to do 2 times 5 times 9, which is 10 times 9. That's 90 times the cosine of C. And this next spot is where people will make mistakes in the law of cosines, because that 108 minus 90 is really pretty. People really want to go ahead and subtract 108 minus 90. But you can't do that because that is an act of subtraction, and 90 is being multiplied by the cosine of C. So we cannot subtract before that multiplication is carried out. And since cosine C is a variable, I can't really do anything with that. So to solve for the C, what I need to do first is subtract the 108. I'm going to move the 108 over, and I'll do 64 minus 108, which is going to be negative 44, equals negative 90 cosine of C. Now we will divide by the negative 90. Divide by negative 90. And negative 44 divided by negative 90, I'm just going to write as 44 over 90. That does reduce, but it really doesn't matter because I'm about to put the next part in the calculator. And that next part I'm going to put in the calculator. If I want to solve for C, I need to separate it from the cosine. We're trying to find an angle, so we have to use the inverse cosine of 44 over 90. And the inverse cosine of 44 over 90, we'll punch that in the calculator. Second inverse cosine, 44 divided by 90. And I am getting an angle of 60.73 degrees. 60.73 degrees. And that was all that was requested up here. So 60 point, and I just forgot the answer, 73 degrees. So there is one law of cosines example where you're using law of cosines to get the angle, and that is a little bit more complicated because you can't throw it all in the calculator at once. like we did when we were solving for a side length. So we're going to do one example of a law of cosines, and then I'll show you the answer to number 4 if you want to do that one on your own. And so we're looking for angle A, angle C, and side length B, and you see what's given. And as in the previous problems, I'm going to draw the triangle because it just makes it so much easier for me. And I'm looking at what I have, and I see the angle 80 is provided. Oh, highlighter, there it is. The angle 80 is provided, and the unknown is the opposite side. And with that, I know that my angle 80 and my B must be on opposite sides of the equation. I also have the two other side lengths given. This is the side angle side presentation of the law of cosines. And as I set that up, B is the one that's by itself. It's going to be on the left side of the equation. B squared equals, and then my A, side length A is 10, side length C is 7. So it'll be A squared plus C, 7 squared, minus 2 times 10 times 7 times the cosine of 80 degrees. And this is the one where I can throw it on the calculator in one big step to get that right side. So I'm going to do that. 10 squared plus 7 squared. And this is the good thing about these calculators is scientific calculators understand the order of operations. And I think I just hit too many parentheses there. I did. 2 times 10 times 7. And just always double check, make sure things are going in the calculator correctly. And this looks good. I now am only lacking the cosine of 80 degrees. And as I hit enter, I find out that B squared is 124.689. And then we will square root both sides of the equation to get B, the side length B, is the square root of that previous answer. And I showed you that trick just a little bit ago. So the square root of the previous answer, and I am getting 11.17. So there's my side length B, 11.17. Okay, now here's the good thing with triangles like this. Once I solve for one of the side lengths or the angles, we can kind of reset our thought process. We don't have to use the law of cosines every single time. Now, I did have to at the beginning. This would not set up. We cannot use law of sines from the beginning. But now that I have this, I can actually channel the law of the law of sines to get either A or C. I think I'm going to find angle A next. And what I can do is the law of sines, because I now have a side length opposite 80, and I can say that the 80 divided by the sine, oh, that's backwards. Okay, first it's 11.17. Make sure the side length is by itself, and whenever you write sine or cosine, the thing that goes inside it must be an 80, an angle, I mean. So 11.7 over 80 is going to equal, and then if I want to solve for angle A, I'll do the side length 10 over the sine of angle A, and now I can solve that. And it's a little bit more convenient, maybe not a little bit, it's a lot bit more convenient than using the law of cosine. So I'll cross multiply here, and I'll have 11.17 times the sine of angle A is equal to 10 times the sine of 80 degrees. We'll divide by 11.17. The sine of A is 10 sine of 80 degrees divided by 11.17. And then A, since we are solving for an angle, this is where you use your inverse sine, the inverse sine of all of this garbly poo up here. So 10 sine 80 degrees divided by 11.17. And we will go to our fancy schmancy calculator, and I like to throw that in one big step. I think it's safest that way. I know it guarantees better accuracy. So the inverse sine of 10 times the sine of 80 degrees, and always just get in the habit of double checking the mode of your calculator. We've been in degrees the whole time. There's no reason for this to have swapped, and it has not. I'm going to divide by 11.17. Where's my 1? There it is. I did not need parentheses down there. 10 sine 80 over, okay, double check your entry. That is correct. And I'm getting an angle of 61.84. So angle A is 61.84. So I'm going to be coming back up here, 61.84. I'll put that in for my angle A, 61.84. And now to get angle C, I have two angles of the triangle. I'll just subtract those from 180, and angle C is going to be 180 minus 80 minus 61.84, and I get an angle of 38.16. And I know these are long, exhausting problems, and you're probably ready to move on to the next question. But very quickly, I want to make sure my largest side is opposite the largest angle. My largest angle is 80, 11.17 is the largest side. My smallest angle is 38 at angle C, and the shortest side is opposite that. So I always it takes like 2 seconds, double check and make sure that that is lining up correctly. Just makes me feel better about my answers. And like I said earlier, it doesn't guarantee that you are correct, but at least the answers are reasonable, and I like that. So here's my work for number 4. If you want to try this one on your own and then check your answers, you can do that. So I'm going to delete the covered up solution there. And here's my number 4. It was more difficult because if you look at number 4, we were given all of the side lengths. And so if you have all of the side lengths, you must use the law of cosines first to get one of the angles. You can choose whichever angle you want. I chose to start by finding the angle A. So I'm just going to talk through this one really quick. So I wanted to start by finding the angle A. And so I put the side opposite A by itself. Angle A is over here. And then again, this one's bad because you're not only finding an angle, which is a more complicated use of the law of cosines, you also have a bunch of really ugly decimals. So just be careful with your calculator. So I did my 2 squareds and I added those to get 2048. I did -2 times those two, and we have to subtract the 2048, divide by the 1895, and then you can see my work. I'll scroll on down, and yeah, look at that. That is a lot of work because we're finding angles. And remember, when you're finding angles in the end, you must put inverse sine or inverse cosine. You can see I chose to use the law of sines to get angle C. So down here, I have law of sines to get angle C. And then once I finally had 2 of my angles, I got the third angle by subtracting the 2 that I had found from 180. It's a little bit easier. So there's that. And I'll scroll down again if you need to pause the video to check your answers and see my work if it makes sense to you. Hopefully it does. And then here are the answers up here. And I am not going to even attempt to do number 5 because this is already long enough. And I think we need a break.